So welcome back everyone. I'm Rahul Kumar, subject matter expert at SecureDApp. Today we are talking about something most developers don't want to hear. Your smart contract might be live, audited, functioning perfectly, but it could still be hiding threats no one has spotted yet. And here's what keeps me up at night. Most Web3 exploits they don't come from complex sophisticated code. They come from hidden assumptions, tiny oversights, edge cases buried so deep inside your contract logic that even experienced auditor miss them. These threats don't announce themselves. They don't shout. They whisper, quiet, invisible, patient, until one day someone finds them. And when they do, millions disappears in minutes. Today I'm going to show you what these threats actually look like and how they hide in plain sight and how tools like Solidity Sheet, Secure Watch and Audit Express help uncover them before the attackers do it. Section 1. The silent killer living on your contracts. Here's the uncomfortable truth. Smart contracts aren't hacked because they are poorly written. They are hacked because developers trust them too much. You write your code, you test it, it works. You deploy it, everything seems fine. But inside every contract, even the good ones, there are silent killers waiting. The unchecked external calls that assume other contracts will behave, assumptions about user behavior that will be violated, overdated libraries with known vulnerabilities, hidden state dependencies that create race conditions, edge cases you never thought to test. And here's the thing, hackers don't exploit your main logic, they exploit the shadow logic, the unexpected interactions, the forgotten conditions, the parts you wrote months ago and never revisited. The code that works 99.9% of the time but fails catastrophically that one time no one anticipated. Let's move on to the section number 2, the 4 hidden threats developer miss. Let me show you the 4 categories of the hidden threats that causes the most damage. Number 1, the everything works fine until it doesn't threat. These are the bugs that never show up in testing. Your contract works perfectly in development, in staging, in your first 100 transactions. Then one day, a user inputs a value you never expected. A liquidity pool runs empty. Gas prices spike to unpredictable levels. A single state variable hits an extreme number. And suddenly your contract behaves in a way you never imagined. I've seen a contract fail because someone withdraw exactly 0 tokens. 0. The developer never tested for. This is where Solidity Shield becomes invaluable. It flags logical edge case risk, overflow paths, and unexpected execution flows that slip past manual audits every single time. Because humans are pattern matches. We test what we expect. Tools test what we don't. So for this, let's move on to the second one, the hidden attack surfaces through integrations. Most contracts don't exist in isolations. They integrate with tokens, pools, oracles, DEX routers, lending protocols, and that's where hidden threats live. Your code might be perfect, but what happens when the oracle you trust starts returning stale data? That token contract you interact with gets upgraded. That external pool changes its fee structure. That price feed gets manipulated. If one dependency behaves differently, your entire contract becomes vulnerable. This is exactly why runtime monitoring tools like SecureWatch exist to continuously watch contract behavior, external calls, and integration patterns to catch deviations the moment they start happening before they become exploits. Let's move on to the third one, the innocent looking functions problem. Some functions look completely harmless, standard stuff, right? But what if they can be triggered repeatedly without cooldown? They rely on block timestamp that can be manipulated. They trust external input without validation. They accidentally reveal private information through events. These are the trap hackers love. The incautious function that becomes a weapon in the right hands. During audit express review and comprehensive security audits, these boring functions often contain the real vulnerabilities, the ones hiding in plain sight. Let's move on to the fourth one, the time bomb threat that activate later. These are the most dangerous category of all. Delayed activation vulnerabilities, a function with minimal checks today, completely safe, but fast forwards to 6 months. Your total value look grows from $100,000 to $50 million. User activity increases 1000x. Liquidity patterns shift dramatically. Market conditions change. That same function, the one that was safe at launch, suddenly becomes a loaded weapon. The vulnerability was always there. It just needed the right condition to become exploitable. Threats evolve over time, and only continuous monitoring catches them before they detonate. This is the reality of DeFi security. Your contract isn't static. The environment around it never stops changing. Let's move on to section number 3 of the video, how to detect and destroy hidden threats. So how do you actually find these hidden threats before someone else does? 4 strategies that work. Number 1, think like an attacker. This means questioning everything. What if this happens? What if this input is at its maximum possible value? What if someone calls this function 1000 times in one block? What if someone manipulates the transaction timing? And what if this external dependency completely breaks? What if two users call this simultaneously? That mindset alone prevents half the vulnerabilities that make it into production. Stop thinking like a builder, start thinking like someone trying to break you what you built. Number 2, use automated threat scanner. Manual code reviews are essential, but humans miss patterns. We get tired, we make assumptions, we focus on what we think matters. Automated scanners like Solidity Shield don't have those limitations. They detect hidden control flows, state manipulation risk, dependency vulnerabilities, subtle logic gaps that would take a human auditor days to find. They find what you don't think to look for. Third would be monitor contracts after deployment. Here's a hard truth. Most hidden threats only reveal themselves when your protocol interacts with the real world, real users, real market conditions, real attack attempts. This is why Secure Watch is essential. It catches live anomalies, suspicious transaction pattern, exploits signature forming in real time. The moment something looks wrong, you know about it before it becomes an headline. And fourth, review your code regularly. Just because your code was secure at launch doesn't mean it's secure today. New attack vectors emerge every month. New integration change how your contract behaves. New liquidity pools create new attack surfaces. The Web3 threat landscape never stops evolving. This is exactly why Audit Express exists, to offer fast, updated, continuous security checks whenever your protocol evolves. One audited at launch isn't enough. Security is a process, not an event. Let's go to the final thing and the final reality check of the video. Let me leave you with this. The biggest threat is your smart contract, isn't some genius hacker. It's the vulnerability sitting inside your contract that you never noticed, the assumptions you made without realizing, the edge case you never tested, the integration you trusted too much, and the hidden threats are real. They are subtle, they are quiet, and they are everywhere. But here's the good news, if you understand how they hide and you use the right tools to expose them, you'll stay far ahead of even the smartest attackers. Security isn't about being perfect, it's about being thorough. So, thank you for watching the episode number 2. In the next episode, we are revealing the mistakes even top Web3 developers make without realizing it. So this is Rahul Kumar from SecureDApp. Stay alert, stay secure, and always assume there's something hidden in your code until you prove there isn't.